So thank you, Sarah. I'm deeply sorry. I can't put the video because my connection is not good enough, and I have to connect with my smartphone. So I will try to be good enough. So you can go to the next slide, Sarah, if you mind. Yes, so discussions of today. So we will try to make those discussion presentation in 1 hour. So we will finish at 8:30 UTC to discuss first some general news we have about the project. My voice is down. Damn, my connection is awful. I'm so sorry. So we will try to discuss first the general news about the project, and particularly the news about the development of the web interface we will develop for you guys. And in the second point, we will give you some scientific news about first a reminder of what will be our main scientific targets for during the LIGO Virgo 04 run. We will have news from Sarah, I guess, for this, or Michael. And whoa, I don't have any screen. Ah, yes. And then we will give you some news from the Grandma collaboration, some updates we have inside the Grandma, newcomers, etc., and new projects. And also some news about the LIGO Virgo scientific collaboration. What is the status right now of the GW detectors, and what has been the first result of the last O3 run. And finally, we will just have one slide to make a proposal for you to participate to a kind of training campaign before the O4 run, to be ready to observe the London sky. We will make some proposal to observe, so to make some follow-up observations of some transients that we are interested in, but we are really happy to hear your feedback about this also. Yes, you can go to the next 2 slides because the next one is just a dead slide. So let's go to the general news about the project. So mainly about the development of this web interface we will try to propose you next year. And you know, as we discussed last meeting on October, this web interface will serve us to send to all of you the different alerts, particularly the alert of gravitational waves, and you could use it for posting your images and so on, and follow the alert campaigns. So we started, we started well before, but I started the timeline on September 2020, where we had to finalize the kind of requirement documentation and all the presentation of the project, so that we could present this to different developer teams, web developer teams. We started to make a hiring process to communicate our project to different developer teams, and to choose some developers on let's say November or December 2020. So we made all the selection phase of the developer teams on November 2020, after many meetings with them, some feedbacks from them for the development of the tools, and some feedback from our team, and so on. And so after this selection phase, we finally found our developer, for our web developer, to make the job for the next year, to develop this hopefully amazing application, web application. We are now on December 2020. We are still, but it's in a good way, I would say, securing, you know, the involvement of the IT department of our laboratories, because we need a technical supervision of the project by people who knows what is the web development. Me, I am a scientist, I'm not a web developer, so I can't guarantee that I will be able to follow everything. So we have involved the people in our laboratories, engineers, technical people, to follow the process, so it's in the good way. And normally you should know, but the website of the Grandma Scientific Collaboration, but also, you know, the first version we try to publish like 2 years ago of the Kilonova-Catcher website are hosted in the IGC lab. IGC lab is located in France near Paris. And so we are securing this this involvement of the technical people of our laboratories in the project. So officially, the project, the developer, the web developer should start the job, the first development on 15th of January next year. This is the official starting date of the development. We will have, well, in a short, I mean, in brief terms, we will have 2 phases. The first phase to really push forward the developments of a beta version of this web application, like from January 2021 to March 2021. We really hope that we will have on March 2021 a kind of beta version of this website, complete website, like maybe something to improve, but we will add to this beta version of the website, and all along the process of the development, some beta test session, I would say. The organization, we still have to think about it, but we need beta testers as we required the last meeting, and many of you answered to this requirements, so it's really good. And we will have a second phase where we will secure the development of this beta version up to a production version of this website. So by June 2021, we will deploy the website on internet for public access to everyone, and we will have a production version that could be used on online mode and with all the functionalities we hope to be able to develop. So that's the timeline. You can go to the next slide. Yes. So just a brief reminder, who are the people right now who try to make our dream comes true? So this web application. So I would say that the scientific supervisor are me, Damien, and Sarah, of course. We have a professional astronomical experts, the guy we call the professor, who is Alain Klotz. Maybe some of you know Alain. He's professor teaching at the University of Paul Sabatier in Toulouse. He's working at the Institut de Recherche en Astrophysique and Planetologie in Toulouse. And we have also a kind of reference in the world of the citizen astronomer, who is Antoine Caillot. I don't know if Antoine is connected, but Antoine is also living in Toulouse. So our new developer, our new hiree, welcome to him. I don't know if Frédéric Carbin is connected, but so I asked him if he could connect, but I don't know if he had time to do. No, I was not here, but okay. Can you go to the previous slide quickly?
Well, 1 second, Damien. I just have a message from Mark about that there are some guests that are on the GTC. Mark, can you tell us if you succeed to say that it's like Slack, Zoom?
Oui, j'ai lu le message.
Ah, donc
yes,
tu leur as dit? Ok.
I said, yes, I said to read your last message.
Okay. Bon, we'll see. If not, I can resend the email.
Heinz Bernd was there, and I see him now, but there was Chinese invited, and I don't see them now.
Damien, it's because we did not redirect to Roma. Okay, let me redirect to. Okay, well, it's because we invite both you and Grandma, and Damien is said that, you know. Well, okay, got it. Okay, thanks.
It's okay.
Yeah. Michael, can you just redirect the Zoom link to Grandma?
Yep.
Grandma list? Yes.
Yep.
Okay. Yeah, you can go on.
Okay, so yes, so Frédéric Carbin is our new IRE and our web developer, and we have also the technical support of the IGC lab for the technical support, and also for the scientific support, we have of course all the grandma scientific collaboration to help us on this project. So final slide for me about the beta test will be very quick, and then the beta testers. So this is what I have in mind, but I have to discuss this with Frédéric Carbin, our web developer. But we would like to have all along the development of the web site some beta test session when some functionalities will be available to propose to you in order to validate or also to kill the tools that we are developing for you actually. So the organization of this beta test session are under discussion. We have to see how with Frédéric how we will organize this, but as soon as we have some ideas, we will let you know. Also about the validation procedure on the calendar, we will define it with Frédéric Carbin, our web developer. So currently the list of beta tester I had, but I'm not sure if I had all the people because maybe I lost some mails, but are those people that are seated here? So I have Roger Ménard, I have someone who had a pseudo which was Astrolab Montmégantic. I don't remember the name.
That's Jean-Bruno Desrosiers.
Ah, okay, sorry, Jean-Bruno. So I will change this. We have all these people. We have also, I remember that we have Cepheus 1D, but it was a pseudo also, and I didn't remember the name, but anyway. We feel free to contact me if you are interested in being in this beta tester list, or like you can mail me or you can send a message on our Slack channel for this. Once we will have a clear idea how we are going to organize this beta test session with Frédéric, we will let you know, but don't expect something before the end of January, I think, because we need to develop things before. And final word is like it's thanks for your feedbacks, of course, and your contribution. It's very helpful for us, and it's very nice to have this direct interaction with you guys. So now we can go to the next slide so except if you have any questions or specific comments on this part. It seems no. Oh. It's okay. So don't hesitate to interrupt us if you have questions. We can ask in English and in French, and maybe I can try a bit of Spanish, but I will be ridiculous, I think.
No, and Ulrich, he told me that Ulrich is no, Hans, sorry, is Cepheus 1, so we have our,
Ah, it's Hans. Okay. Okay. So I will change this, of course. Okay, so we can move on to the next topic of discussion topics, which are the scientific news. And so here are the slides you prepared, Sarah. I don't know if you have time to present them or.
Yeah, I will make it. So yeah, just to remind, I don't know if some of you were not at the first station, but just to remind that Grandma is connected to exploring the Violence universe, and especially messenger from this Violence universe. So far we tackled with gravitational wave that have been detected in 2015, and more especially gravitational wave with optical signature. So, and our best events ever is from 2017. So it's very, very new science with gravitational wave. And so we would like to understand more the collision of two neutron star black hole. So far, we did not get any optical signature for neutron star black hole. And this is our goal for O4, for example, I hope. to detect this optical signature and to characterize it. So today I just would like to make a point about this, maybe today, about the neutron star black hole collision. Some of the people always ask me and ask Michael and Damien, lights from a neutron star black hole or two neutron star. So when you have two different compact merger with different mass, in fact, the mass ratio and other parameters, but the mass ratio will tell you more about how matter can be expelled. And so when you have a mass ratio, I think about 2, but maybe Michael can confirm, you will have maybe more matter expelled and more brighter signature than 2 neutron star. But if the mass ratio is so large, then the neutron star can go directly into the black hole, and that we will not expect any light. So that's why for 04 and for 2022 is so excited to still continue this science, because we are only at the beginning and we have to know learn a lot about this astrophysical scenario of neutron star collision and neutron star black hole. And I just want to highlight also today, so remember that we have this gravitational wave from the in-spiral sequence of the two neutron stars and the collision, when the signal of gravitational wave is higher at the collision. We have a matter expelled either isotropically, which is a Kilonova-Catcher, and also the matter expelled from a beam that is oriented towards Earth. And we have the slowdown of this beam jet toward Earth that will emit light from X-ray to radio. And so today I said to you before that this afterglow, so how the jet is slowing down into the cold environment, is still observing. So after 3 years, we are still observing the emission from the afterglow, so the slowdown of this jet. And so you can see we just received a circular from well, I have some problem to read it. Okay, 14 of December about that they say that it might still observe the X-ray emission from this afterglow. So even if it is at longer, since a lot of time that we have made this observation of the kilonova in optical, this event is still observing, and we still learn from it 3.3 years after. So about GRANDMA, so I showed previously that GRANDMA is an international collaboration for 14 countries. There are different observatories from 29 international groups. And we are on the discussion to integrate more groups, more countries, especially in Morocco, in Hungary, and in Kazakhstan. So it's nice because it populates this region, and Morocco is quite nice, and Ukamaden to have a good site also in Africa. And Hungary also makes the bridge, so it's nice. There are very few places still in Europe, that you can observe with not light pollution so much. So we are on this way. We are still struggling to cover this part. Yeah, so that's why we rely really on the astronomer amateur in La Réunion, and also I know that some of you are in South Africa, even if they are francophone, but anyway, that's why it's more than important if you are friends, amateur friends that is on the south part, please let us know so that we can cover this part. Also, you have a USA contact, of course, of Canadian, yeah, anyway, so this is a professional, but I know from the amateur. And also recently for 2021, we are very glad with Damien and Michael because we obtained again some time on professional time for CFH, that is a Canadian French Hawaii telescopes, and it's a 4 meter, and so we are still having some time for Hawaii, so it can cover well or this 24-hour observation. Okay, so Damien explained a bit Damien explained a bit the concepts of the web platform where we are. We try to be very transparent to you, and also that you can have about a knowledge how to construct a project, scientific project, and what are the deadlines, what are our struggle, etc., etc. So in GRANMA, because there is no gravitational wave, and you have heard until 2022, we try to extend our scientific programs connected to this violence universe. We're still like this, this collision of two neutron star, black hole. And so for that, we have two ideas that we're gonna develop, and attached to that, it will be a citizen science program, so the same that we use. And so we will invite you to participate. And so the number one, is the neutrino. So it's another messenger that we did not detect so far for the collision of two neutron stars, but maybe we hope. And so especially the high energy neutrinos from IceCube, which is an observatory, a neutrino observatory. So we will follow up in GRANMA professional this neutrino, and we will invite you to follow up neutrino as well. So it is exactly the same strategy as gravitational wave. We will give you some tiles and we need to find the counterpart. So normally it's not, so for the neutrino, it's not only collision of two neutron stars. In fact, we don't know much about the nature of this counterpart, but it can be also associated to the jet that I talked about before. The other program that we will develop in GRANMA, and we are on the way, is to find kilonova from survey of telescopes. So the telescopes that they survey a large portion of the sky every night, and they can, I don't know, they can find a kilonova, serendipitously. Well, it's very difficult to say it, but par hasard, let's say. And so the idea is that if we find something that looks very close to a kilonova, the idea is to say, hey guys, we will follow up. And so also we will redirect to you this kind of kilonova candidate that we will follow up with GRANMA. And Michael is developing actually this program in the USA with another team, and also for GRANMA as well. So as said Damien, we will organize in the parallel to this platform development. This we will invite you to follow up this different transient, it's always transient astronomy, I'm sorry, connected to the violence universe, and we will come back to that later at the end of my slide, at the end of the presentation, so that we can a bit more discuss about that. But basically, we will continue of the follow-up and invitation with you on Slack or redirect by email as it was before, and as soon as the platform is not mature, we will switch to the platform. So some news about also communication, because there was one of the aspects that you asked. So for the moment, I encourage you to, so I try to ping, I mean, it's not me, but a person that is on the project, to ping news from the GRANMA project when there is an article about GRANMA and so on and so forth on LinkedIn. So if you want, you can follow up, or how to say, connect, or I don't know, subscribe maybe, I don't know how LinkedIn works, but to the GRANMA project. And we have also, so this is just news like, hey guys, there is an article on X and Y, for example, the radio, it's more in French than in other language. And we have also a YouTube channel where when it is at more scientific level, it's more like, PhD level, I don't know how to say it, but you can try to have a look. When the idea is to invite people around our GRANMA consortium, so people doing astronomy nuclear, or nuclear physics, or something like this, people that are from other competitive groups, not our group, but other groups, to have feedback about how is their functioning. to have from people about more theory, about the expected rate on this Kilonova. So to create all this community ecosystem around grandma that enrich our collaboration and give new ideas for the science. And also I promise to you guys about the method scientifique. Voilà, I have, je ne sais plus la radio. Bref, voilà, France Culture. So I promise that to one of you. And we will have just before, so what I asked, we will have just before, you know, les journées, les rencontres ciel-espace in France, this radio interview of maybe one of you that will highlight the project and that will highlight, and I hope there will be more and more participation. So this is only for French, but at least I did my job. All right, so we have another news. Well, no, the news. I don't know if it is the news. I just try to. Okay, Damien, I don't see the chat. So if there is something about the chat, just let me know. So we have, so because gravitational wave detector will go in higher sensitivity, right? We will go look further. Then the telescopes need to be more sensitive. If you stay at your level that you were in O3, it is perfectly fine. It's just that you will have maybe less chance to observe the kilonova because you will only be sensitive for the very close universe, let's say. But some of you that can reach more and more sensitivity, they will be, they will be detect kilonova in a bigger volume. This is simple. Okay, so for the professional side of grandma, we need to really be at the same volume sensitivity at the gravitational wave detector. And that's why we are thinking about new system that we call Eurovision Transient Facilities. That's because it's a combination with a lot of people from grandma, so that's why. And so the idea is to have 80 robotic centimeter, new one that will have all the characteristics to tackle gravitational wave, 404, 405. So let's say that we plan to install it before 2030 with the filter that we need for our science, and will cost less than $500,000. And so some of our colleagues in grandma, they have the opportunity to install this kind of design of telescopes that we are making in grandma. But I was thinking also to have a push, you know, to have one in France, and especially in south of France and in the downtown. So I just highlight that for you, because if you know a very good site, if you want to be part of that project also with us, and you can help us to maybe maintain it, or I don't know, under your association that you have a very good site, please let us know, because it's very important also, I think, for new project like this one to include.
Sarah?
Oui?
We have a question from maybe
Stop.
It's okay. We have a question from Michael Richmond, who is asking, is the plan to create a mosaic of these small cameras, and how many?
I think it's a question more for Michael, but here we wanted to use this camera from China. Okay, honestly, the little story is that I was very, very glad, because thanks to our connection to China, the camera will arrive promptly to be tested here in France. But we didn't shoot this kind of mosaic camera. I know that it's much more difficult, but maybe Michael has an opinion about that, but this is not the choice that we made for the moment. So I don't know, Michael, if you want to react on that.
No, Michael figured it out. He pointed out that with that one camera, you get a degree and a half or so. So it's a large camera. So you can do the whole field with this one.
Okay. Yeah. It's a large camera. So yes, to come back to my idea, I know that, you know, so in France we don't have the money, voilà. But the other countries, they can have the money. So the idea is like we should make a whole push to all together, maybe have some time on this telescope that is dedicated for you for other science or for I don't know what. So it was my idea. I just submitted to you. Let me know. But yeah, this is in any case, this is the type of instrumentation that need to be done here at Europe or Eurasia continent, because in USA you have this kind of facilities or this kind of project, whereas us, we are a bit low in Europe for this kind of things. Okay, so let's move on. I hope that I am not too long. Michael, what about that you can take this lead for LIGO Virgo? So Michael is I am from Virgo, from the Europe side of the LIGO Virgo project, but Michael is from the LIGO side. So maybe since he there can show our results about LIGO Virgo. So it's independent from Grandma, right? It is just about LIGO Virgo.
Sure. So as many of you are aware, within LIGO Virgo, we just finished our, well, it's been since March that we finished our third observation run with the network of interferometers, a couple in the US and one outside of Pisa. And in the last couple months, we have published our latest catalog of results based on the first half of this observing run. So typically, at least recently, we split observing runs into kind of halves, where at halfway through we upgrade the detectors and so on. And so we published a catalog that covered this first half of this observing run. Next slide. So one of the most important things for this particular group is basically to have the greatest sensitivity as possible for our detector network to binary neutron stars in particular. So of course, as Sarah and Damian mentioned, this group is looking for kilonovae and therefore for objects that have binary neutron stars. And so these plots show the relatively substantial improvement that the detectors achieved between O2, which was in sort of the lightly shaded version here, which was the observing run from a few years ago, where we found the binary neutron star and its counterpart, and then moving to the first half of the third observing run. And so you can clearly see, up to a 50% improvement, which so on the left-hand side, and if you move to volume, it's of course even more than that. So in general, we had I would say overall instrumentally, a very successful run. Okay, next slide. So, one of the unfortunate parts about running a gravitational wave detector is that they are susceptible to not only detecting astrophysical events from black holes or neutron stars, but we are quite plagued by things like seismic and magnetic noise, so things like earthquakes. And so one of the results of this is that our duty factor, where duty factor is simply the amount of time that we have available for running our detectors, is less than 1, essentially. And so while this has been improved between O2 and O3, so you can see at least on the LIGO side, the Hanford and in Livingston, our duty factor was something around 60%, and then bumped up above 70% during O3A. We still have a relatively limited time when all 3 detectors are available. And so the reason that this matters for this crowd in particular is that in general, we're able to detect gravitational waves when there's at least 2 detectors up and available to detect things. We have some instances where we found where we've confirmed gravitational waves from 1, but that's relatively limited. But you'll notice that the time where we have 3 detectors is less than half, and this is really important because it changes our ability to localize the signals, and therefore the sky region that we have to look over is relatively is only really small when we have all three detectors available. Okay, next slide. And so this is a nice plot to showing the sort of the cumulative number of events of all types. So this includes binary black holes and binary neutron stars through O1 and O2 and O3. And so I think it should be clear based on this, the kind of improvements that have been made during O3A. There's a, we are at right around 50 confirmed events right now. And the expectation is that once the O3B catalog, it'll be once again nearly doubled. And so I think this demonstrates the sheer the excitement folks should be having looking ahead towards O4. The number of gravitational wave events that are to be followed up are increasing quite rapidly, even relative to a few years ago. And so, yeah, next slide. So so this is a little technical, but in general, one of the things that makes gravitational wave detection both fascinating and let's say troublesome is the number of algorithms that we have available to us to search for these things. And so, for example, we have some subset of pipelines that are dedicated towards finding compact binary signals, i.e. these binary black holes or these binary neutron stars, as well as a couple of pipelines that are more designed for things that we model less well, such as supernovae. And so altogether, these pipelines form our sort of our low latency alert system, i.e. our way to take gravitational wave strain and produce information such as sky maps that we use to search for candidates. And so altogether during O3, this pipeline put out more than initially 80 alerts, which was of course very large number. Some small fraction of these were retracted in relatively low latency. So as I kind of mentioned, our detectors are subject to noise sources and so on. And so when that happens, we retract the signals as quickly as possible. But for a vast majority of them, they were released in low latency and were deemed eventually to be still of significant interest. And so at the very bottom of the slide, you can see we have order 10 or so objects that are likely to have at least one neutron star in addition to many of our binary black holes. Next slide. And so this is the what we call our stellar graveyard plot. And so this is, you can see at the top line, or the sort of towards the top here, we have our blue black holes that form larger black holes, of course. And this is, and you'll notice even some of the smaller black holes that are here. And so we're really starting to probe some of the, an area of astrophysics that really previously was only for these low mass X-ray binaries, for example. We also now have a couple of likely binary neutron star and neutron star black hole systems. So during O3A, we have one binary neutron star system and one potential neutron star black hole system. And the expectation is during O3B, there may be some more. And so we're really starting to fill out this plot of sort of the parameter space that's available to us in terms of compact objects. Next slide. And so so this slide highlights some of the let's say the big results from just from the first half of O3. So for example, one of the first binary black holes we found had highly asymmetric component masses. So basically one of the black holes was relatively larger than one of the other black holes. And so this is cool for not only for astrophysics in terms of how you form these black holes. You expect, depending on the formation channel, you might get different things, basically different mass ratios or different amounts of angular momentum. And so this is the kind of object that allows us to probe that. In addition to, for example, GW 190814, which is near the bottom of this list, which is one of these we had a relatively large black hole, 20 odd solar masses, with something that was around 2.5 solar mass compact object. So maybe it was a neutron star, maybe it was a black hole, but again, you know, these gravitational wave detectors are starting to find objects that we just simply didn't really know much about before at all. Next slide. Okay, I think that's someone else.
Yeah, I think it is my turn to finish. Or so to come back and to have a small discussion with you. Oui, tu veux le faire?
Non, pas forcément. We just had maybe a question for you or for Michael about. We had a question from Marc Serrault about why such a difference in sensitivity, between GW observatories. For example, between Virgo and LIGO, but also between the two LIGOs. What makes such a difference in sensitivity?
So I'm sure Sarah can take this as well. So as is mentioned in the chat, gravitational wave detectors are very complicated. But I would say that, so for example, Virgo and LIGO have taken different designs tactics towards reducing the seismic noise. So for example, Virgo has this 7-stage inverse pendulum where they literally hang the mirrors off this very large giant set of penduli. Whereas LIGO does more sort of things like active control to reduce the seismic noise. In addition, one of the main differences currently is in terms of the ability to have the detector take data at different power levels. So of course, these interferometers are using lasers, and our sensitivity is really set by the number of photons that we can keep in the interferometer arms. And so the different detectors have been more or less able to have different amount of light levels in their detectors stably due to that. And so then, you know, things like mirror coatings and such really come into play there. But anyway, so it's a mix of sort of well, to some extent technology in terms of design choices that have been made, in addition to a bit just luck, you know, what has worked and what hasn't in terms of what has been able to be run stably throughout these observing runs.
Yeah, I would like to say also the site. I think the Virgo site is not the best location between the mountain and the sea, maybe. And of course, maybe just funding, you know, that maybe we don't have all the possibilities and US have. So, all right. So I will finish with so the possible source that we invite you to observe. So it will be on the Slack, as I said, starting in February 2021. So the first one, we will redirect the swift gamma ray bursts. So gamma ray bursts are associated, as we say, to the relativistic jets. And so we want to give it to you because both it is scientifically interesting, it is driven by, I mean, death of massive star or collision of two neutron star or neutron star black hole, but also we have a technical point to train for, you know. So for example, the swift gamma ray bursts, they are well localized, so you can have for you sources in, sources to find, and sources in at the center of your computer. Is not like gravitational wave, but the challenge is that the brightness is rapidly decay. So within like 12 to 24 hours, it is very difficult to observe. So we will help to, for example, to try to win this race and to test the reactivity of the observation of the networks and to practice on reactivity. But it won't be difficult because if it is enough bright, then it is in the center of your telescopes. And with Damien, we were discussing if we redirect only the one that can be observed within 24 hours, for example, not the one that are already faint, you know. not to disturb you with something that will be too difficult. The second category, as I say, the neutrinos that are also messenger by IceCube. And so it's very interesting to follow up because it is a multi-messenger sources. We don't know much about the counterpart, so it's, I mean, if someone got it, I mean, it's just like the Nobel Prize. No, I don't know, but it is very, very challenging and very exciting. And for us, it will help to practice on GW system because the neutrinos are not well localized. And so we need to give you 2 or 3 pointing, and we don't know where to point, so it is exactly the same as when we give it to you some field without sources at the center. And the last one is to continue on Kilonova. And so that's why we think about Kilonova candidates that Michael or other will reject. And there were also some proposition about more variable bright sources or transient with slow decay as assassin, because maybe then this is much more easy. It's not easy, but it's much more easy than the 1, 2, 3Ks above, because it's low decay. So maybe you will have time to practice, and we can interact together about the photometry, about the image, and so on and so forth. So it's also another possibility to really explore all the steps when we will face some gravitational wave.